Good afternoon all. Just a quickie for my patrons. This light that's out the front of the house, which is a PIR sensor, really designed for indoor use, and a sealed 10 watt LED, was connected to a 12 volt battery, and then this long wire which runs round the front garden, and then along the side of the house here, and to the back to a 12 volt car battery, a big one. 18 ohms this cable if you add the resistance of both connectors. Well, now that wire is going to a supercapacitor bank, one of those little blocks of 6 supercapacitors, and these things can take up to 16.2 volts. This one doesn't have the little indicator LEDs on it, not yet anyway. I might add those on. I put a little rain cover over that so that it doesn't get directly wet from water, although of course it might go on that brick. We'll see how that works. And I have to say that this thing works astonishingly well. This is the first application I've found for one of these supercapacitor blocks where it's actually useful, and it's completely brilliant. Let me show you. If I trigger this, I have to block the light out so that it comes on. That thing comes on at full brightness, and it's only set for 20 seconds, so it doesn't stay on for very long. And the supercapacitor bank drops from, well, I've only ever taken it up to about 11.5 volts, and it drops down to about, I don't know, there's an equilibrium point at 10 volts. So at 10 volts, even with the light on, the light's very dim of course at 10 volts, but at 10 volts that capacitor bank is still charging from that pair of wires coming from the battery around the back of the house. Above that, if the light comes on, then the capacitor voltage drops to about that 10 volts. As I say, that's an equilibrium point. But I just thought you guys would like to see this before I officially unveil it. It just works brilliantly. I'm extremely happy with it. And as I say, that's really the first application of one of those supercapacitor blocks that I found. And it's awesome. Cheerio.